Hello everyone. Today in this video I'm going to talk about chemical reaction. Chemical reaction is a process in which one or more substances are converted into one or more different ones. Chemical equation is a short way or shorthand of describing a reaction. It provides information about the reaction, such as the formulas, states, and number of molecules of reactants and products. We generally use G to represent gas for the state, L for liquid, S for solid, and AQ for aqueous. There is a difference between liquid and aqueous. Aqueous is water solution that the substance has dissolved in water. We have classes of chemical reactions. The classes of chemical reactions are based on common characteristics that the reaction displays. Number one, we have synthesis reactions. In this reaction, a single product is produced. A single product is produced from two or more reactants. In this case, we have two reactants, A and B, and producing single product. The main thing about synthesis reaction is we have only one product. So we can say, for example, carbon plus oxygen is producing CO2 gas. So our product is CO2 and is only one. The next is decomposition reaction. In this case, is opposite of synthesis. A single reactant is converted into two or more simpler substances. For example, we have AB and it breaks down into A and B. So, one thing we should remember in decomposition reaction is we have one reactant. Is the opposite of single. In the synthesis, we have one product. So let's take an example. We have 2CuO, copper 2 oxide, and it breaks down to copper plus oxygen. This is a decomposition reaction. One reactant and two or more products. The next one is single replacement reactions. In this case, one element within a compound is replaced by another element. So we have to watch out for the element that is being replaced. So we have this compound AB and C forming CB. We can see that this C replaced A in this reaction to form this. So let's take an example. We have zinc plus H2SO4. And we have zinc sulfate and hydrogen gas. So we can see that zinc is able to replace hydrogen in this. So we call it single replacement. We can use the activity series to know which of the elements is going to be able to replace each other. When we go to the activity series table, those elements on top will displace all the elements at the bottom. We have some elements at the top and bottom. If you go to the activity series, you're going to see that zinc is on top of hydrogen Hydrogen is below zinc. So zinc is able to displace hydrogen in this reaction. If you go to the activity series, hydrogen is above gold. So in any reaction, gold will never be able to displace hydrogen. In other words, if I have a reaction like this, uh, this is never going to be possible. We're going to have no reaction, right? Because gold, sorry, H2SO4. Gold is not going to be able to displace hydrogen. For double replacement reaction, we have two compounds here and they are exchanging parts with each other to form entirely new compounds. So we can see here that AX and BY is forming new compounds of AYBX. So we can see that this A went with Y and B and X go together here. Let's take an example using this. We have silver nitrate plus sodium chloride, and this is going to give us silver chloride because my silver will go with my chlorine and my sodium will go with my nitrate. So this is an example of double replacement reaction. We can see these two compounds here and they are exchanging partners to form new compounds. We also have combustion reactions. And in this case, a substance combines with oxygen. Right, oxygen is very important for combustion reaction to take place. A substance combines with oxygen to form one or more oxygen-containing compounds. It also emits heat. Combustion reaction come with emission of heat. So these are two examples of combustion. We can see oxygen is present here and we have two or more products containing oxygen compounds. So let's take a look at examples to practice to check what we've done so far. Classify each of the following reactions. We have 5 reactions here. So number 1, we can see that we have 1 reactant and 2 products. So this fits into the description we have for decomposition reaction. Number 2, we have these two we have Fe and copper 2 nitrate, and if you notice in the product, Fe is able to replace copper in this reaction, leaving copper alone, right? Fe is stronger or richer than copper. So, and Fe took over nitrate from copper. So this is a clear example of single replacement. Right. Number 3, we have this reaction. The reactants are 2 and we have only 1 product. So this is an example of synthesis. One product, 2 reactants. So number 4, this we have ammonium chloride and silver nitrate. So we can see that Ammonium here went with the nitrate, and the silver went with the chloride to form silver chloride. So this is an example of what? Double replacement. Replacement. The last example we see here. Our reactant contains oxygen and the product has oxygen containing compounds. So this is combustion reaction. So these are the criteria that we can use anytime to classify reactions that we have. Thanks for watching.